Hi everyone. In previous some lessons, we are discussing about measure of dispersion. We already know about range, mean deviation and variance. Now we are going to know about standard deviation, which is also known as SD, and coefficient of variation, which is known as CV. Let's find out. In previous lesson, we know about variance and how to calculate variance. But there is a problem. When you get the output, we get a squared units, and variance represents squared units and is not appropriate measure of dispersion when we wish to express the concept of dispersion in terms of the original unit. So there is a conflict, and in this situation standard deviation helps us. Standard deviation is nothing just the positive square root of the variance, and it expressed in the original unit of data. So that's why we're going to prefer standard deviation over variance in most of the situation. As we already discussed about the formulas of raw or ungrouped data for variance, standard deviation has similar kind of setup. There's just a difference in the notation. For population standard deviation, we are going to use sigma instead of sigma squared that we have been used for variance, and it's denoted as SD of x, which is standard deviation of x, and this is the square root of variance of x. You have to just square root the variance value and you will get the standard deviation value. For sample, it remains same, and it's denoted small s and small sd of x, and it's the square root of variance of x. And similar way, we using n-1, and the unit is here in original unit, not the square term anymore. That's because of this positive square root. For group data, we have to use this frequency term to get the original value from this frequency distribution data set, and anything we calculated from population is known as a parameter, and anything from sample is known as statistic. Here we have borrowed the previous data set to find out the standard deviation. That's the same process we have to go through. We have did already for the variance. First of all, we need to calculate the mean, and after that we need to calculate the variance. And as we know, this is a square term units, we have to just square root it. A positive square root of variance gives you the desired standard deviation, and this time we get a value 1.83 pounds, which is very less deviation from the mean value. So we can interpret the average variation of the weights of newly born babies from the mean weight is 1.83 pounds. Now for group data, we are going to use the same example, and similar way we have to find out the squared sum of deviation and divided it by n-1, and then take the positive square root, and we will get this 33.59 USD. That's our standard deviation for this data set. And we can say the average variation of the opening price of Netflix Incorporation during the period from mean opening price is 33.59 US dollar. So why do we need the standard deviation if we have the variance? Actually, standard deviation has some wide application compared to the variance. Yes, one of the reason for the unit we have here, but it has some more application or advantage over variance. Let's find out. In stock charts, standard deviation is a measure of volatility. Now, what is volatility? In simple word, volatility is an up and down market movement. Like high volatility brings uncertainty and the scareness to the people, and low volatility gives more stable situation. To know more about volatility, you can see the supplementary part. In stock, the chartists can use the standard deviation to measure expected risk and determine the significance of certain price movement. Is it going down? Is it going up? There's uncertain variation. Everything can be use in terms of standard deviation. Bollinger Bands, a type of charts which is very popular, shows the upper and lower limits of normal price movements based on the standard deviation of share prices. It's also used in many fields of science and business studies. From the variance and standard deviations, we can understand how well a model is when dealing with the dependencies of the data. Now, here the model is referred to the regression model, which we are going to learn later. Although the variance and the standard deviation are useful measures of variation of the values of a single variable for a single population, but sometimes we need to compare the variation of two variables. Yes, we can compare the variation with the measures of standard deviation, but to get the relative variation, we can use coefficient of variation. In some situation, we cannot use the variance or the standard deviation directly because the variables might have different units and the variables might have different means. For comparison, we need a measure of relative variation that does not depend on either of the units or on the values of the means. Their measure is called the coefficient of variation, which is shortly named as CV, and it is the ratio of the standard deviation and the mean. For population CV, we can define it with the population standard deviation divided by population mean, and for samples CV, we can find it by dividing sample standard deviation divided by sample mean. And both cases we have to multiply it with 100 and we will get the percentage value. From the formula of CV, it's clearly shown that CV is a free of unit or unitless measure, as the standard deviation is divided by the corresponding arithmetic mean to make it comparable for different means. So that's why CV is so unique measure of dispersion. We can compare any data set which has different units or different means. You can calculate or you can estimate the relative variation, or you can say you can compare the relative variation of those data sets by using the CV. And that's why overall all the measure of dispersion, CV is the most strong and powerful measure of dispersion. To compare the variation between the two data sets, you need to find the following quantities like the mean and the standard deviation of a data set. Only after that you can calculate the CV and make your decisions. Now, how will we make the decisions, or how can we say which data set has a larger variation? Very simple. As we know, CV is a relative measure of dispersion, not like the mean and standard deviation, both are absolute measure. So in CV we are comparing the relative variation. So which data set has larger coefficient of variation value, that data set has more relative variation compared to the other. So you can say the relative variability of data set 1 is larger than the relative variability of data set 2. That means CV1 is greater than CV2. Then we can say that this data set has larger variation, and the vice versa also can possible. So let's take an example here. The following table provides per share price of Beximco Pharmaceuticals Limited and Orion Pharma Limited, the two pharmaceuticals and chemical companies from DS30 index of Dhaka Stock Exchange during the period of June 22, 2020 to July 22, 2020. Now, check the data layout. We have the data set and the prices for both the pharmaceuticals companies, and this is their stock name BXPH for Beximco Pharmaceuticals Limited and ORIO, which is for Orion Pharma Limited. Now let's find out which data has more variation, or we can say which data has more relative variation in terms of price. As we know, to find out the CV, we need two quantities. One is mean and another one is standard deviation. So for first data set, we have calculated the mean, which is 70.18, and the standard deviation, which is 4.43. Similarly, for the second data set, we have calculated the mean value, which is 42.87, and standard deviation is 1.12. Both have the same mean in Taka. Now, for the first data set, we have calculated the CV, which gives us the value like 6.32%. And for data set, second one, we have calculated, which is 2.62%. So it's very clear from these two values, as the coefficient of variation for Beximco Pharmaceuticals Limited is greater than the coefficient of variation of Orion Pharma Limited. So we can say Beximco Pharmaceuticals Limited share price has larger relative variability or relative variation compared to the Orion Pharma Limited share price. Now there may be a question arise in your mind, why are we not using standard deviation to compare these two data sets? Yes, we can use standard deviation to compare data set, and it gives the same results, because here we can see the standard deviation for Beximco Pharmaceuticals Limited is larger compared to the Orion Pharma Limited. So you can say this data set has larger variation. When we are talking about relative variation, CV provides us more precise results, and you can say it gives us more accurate results in terms of measure of dispersion. There may be a situation where standard deviation can't work. Yes, in this situation standard deviation can work because it has the same unit and different mean. So we can take the decision using this standard deviation if they didn't ask for CV. But there may be some situation where you have to use CV to make decisions, like if you have different units or if you have same standard deviation, then you have to use CV instead of using any other measure of variation. Let's take a situation where we can use only CV. Here we have two datasets from two samples. From dataset 1 we get that the mean value of the first dataset is 66 kg and the standard deviation is 4.5 kg. And for second dataset we have the mean value 36 kg and the standard deviation is 4.5 kg. So you can't make any decision based on the standard deviation for this dataset, as both of them have same value. Now let's move on to CV. What he gives us? The first dataset gives us a CV of 6.8% and the second one gives us 12.5% value. So we can say here, as the second dataset has larger coefficient of variation compared to the first one, so we can say the relative variability or the relative variation of dataset 2 is larger than the relative variation of dataset 1. So if we use the standard deviation to compare the variability of the two datasets, we will wrongly conclude that two datasets have the same variability, because the standard deviation of both sets is 4.5 kg. So that's why we are saying that the using of CV is very important in particular situation. But let's overview where and when we should use which measure of dispersion. In most of the cases, we should use standard deviation or CV to compare several data sets for the variation. If we have same mean value or the different mean value and the same unit of measures, then we can use standard deviation to conclude which data set has more variation. But if we have same or different mean but different measures of unit and same standard deviation value, we have to go coefficient of variation and check the relative variation of the data set and make our decision based on those values. So that's how things working for measure of dispersion. You should try more exercises and problems to overcome or to get more expert when and where we should use which measure of dispersion. Now let's try to attend the quiz below.